Hello, Josh McAvoy here. In this video I'll be showing you how to use Pirate. Pirate is one of the fastest ways to crack WPA and WPA2 passwords for wireless networks. It uses pre-computed PMKs from a massive database in a space-time trade-off to crack a four-way handshake. I will be explaining what that means in this video and how it can benefit you in password cracking. This video starts where we left off in my previous video about AirCrackNG. If you don't know what capture files, dictionary tags, and four-way handshakes are, go back and watch that video first. A link will be in the video description. Let's get started. AirCrackNG is a powerful suite of tools, but where it really falls short is in cracking passwords. This is a painfully slow process. Cycling through a dictionary in the gigabytes range can take weeks or even months. Pirate can use the power of your CUDA-supported GPU to speed through your dictionaries at lightning speed. Just how fast is it? Well, in an attack that took AirCrack 45 minutes to cycle through my dictionary, Pirate was able to run through that same dictionary using a pass-through attack in 45 seconds, which is 60 times faster. What Pirate can compute in 6 days would take AirCrack just short of 1 year. Using Pirate's database attack, that same attack can be done in 1.5 seconds. This is 1800 times faster than AirCrack. These results may differ depending on your hardware, but if you have a GPU that supports CUDA, you might as well put it to use. If you don't already have Pirate installed, follow the link in the notes to get directions on how to get it set up. Installing CUDA drivers for your graphics card is beyond the scope of this video, but I've also included some links to help you find the right driver for your hardware. By typing NVIDIA TAC SMI, you can see the GPUs you have running on your machine. Once you have everything installed, type pirate list_cores. This will show you if Pirate is recognizing your graphics card. If only the CPU cores are showing up, you either didn't install the Pirate CUDA module or you didn't edit the config file. To edit this, type nano.pirate/config. Add the 2 lines that you see at the bottom of this file. If you would like to limit the amount of CPUs that are being used in attacks, change the second line to the amount you prefer. 0 means that it will use all available CPUs, and -1 means it will use none. I'd advise you to use at least 1, as it will need it to add passwords and run database attacks. You can save this file by pressing Ctrl X and then saying yes to overwrite the file. To benchmark Pirate, use Pirate benchmark. Play around with the settings and see what gets you the fastest speeds. Now that we have everything set up, we can now dive into cracking passwords. Here you can see the help page for Pirate. The syntax for input is Pirate, then any options you're using, and then the command. Only one command can be used at a time, but multiple options can be used at once. Assuming that you've already captured a four-way handshake in either AeroDump or Wireshark, type Pirate TAC-R, your capture file, and then analyze. This will analyze the capture file and show you the quality of the handshake. As you've probably guessed, it's best to use one of the good variety. If you've been capturing network traffic for a long period of time, the file is probably fairly large. Pirate has a great feature similar to WPA clean that strips the capture file of any unnecessary information. Type Pirate TAC-R and then the capture file you'd like to clean. Then TAC-O to output the new file, and then strip. Now that you have a clean capture file, let's start cracking passwords. With Pirate, the password attack is similar to that of AirCrackNG. The difference is that you can now use your graphics card to compute the pairwise master keys, which takes up about 99% of the computing. For this attack, you'll need a password dictionary. In this example, I'll be using the RockU dictionary, which can be found in the description. By using the word count, I can see the number of lines in the rocku.txt. This is how many passwords are in the file. To do a pass-through attack, type Pirate TAC-R, your capture file, TAC-I, and then the location of your dictionary file. Then attack_pass-through. As you can see here, it's computing PMKs, or pairwise master keys, for each password in the RockU list, and checking if it matches with the four-way handshake. And here's the password. Now this attack works great, but by pre-computing the PMKs and saving them to a database, you can cycle through the passwords even faster. This is a space-time trade-off. By using space on your hard drive, you can get results faster than a normal pass-through attack. If I type pirate and eval, we can see that I don't currently have any passwords added. To add your dictionary, type pirate -i, the location of your file, and import _passwords. WPA2 requires passwords to be between 8 and 63 characters long. Pirate will go through the list and delete any passwords that don't fit the requirements of the WPA2 standard. Type in eval again, and now the passwords are added. Now we must add our 4-way handshake. Type pirate -e, the SSID of the router, and then create _ESSID. Type eval again. The ESSID is now added. But the 0% shows that none of the PMKs have been computed yet. We must now batch process our PMKs. It will compute and save the keys to our database. The result is what's called a rainbow table. This may take a while depending on the size of your dictionary. Once it's done, simply type pirate -r, the capture file, and then attack _db. This will use the rainbow tables you've just created and check them against the capture file. If the password is in our tables, it will show up in a matter of seconds. And there's our password. This process can take up a lot of space, but it's much faster than using aircrack-ng. If you'd like to make some space on your computer, simply delete the table by typing pirate -e, the ESSID you'd like to delete, and then delete _ESSID. To learn more, view the links in the description. Hope you enjoyed this video.